Well, hello, pre-calculus students and seekers of general truths. Let us talk about discrete probability. All right, so we talked about discrete mathematics and counting, and probability is an extension of this. And we'll look at some simple examples here, but let's define a little bit of what discrete probability is. It's basically a fraction, right? And it is the number of events in the sample space the number of events in the sample space, compared to the number of particular events that we're looking for. Okay, so maybe it helps to look at a few things. So let's say we want to flip a coin, okay, a regular coin. Well, the sample space is as follows. You either have a heads or you have tails. Okay, so the number of events in a sample space, there's two, and if you want to know the probability of a heads, well, then this would be, there's one way of a particular event here would be that there's one possible way for you to get a heads, and the number of events in the sample space, there are two of those possible events. Okay, so hopefully that clarifies the vocabulary. Let's look at another one that's a very common scenario. What if I flip two coins simultaneously? Okay, well, what is my sample space? Okay, well, my sample space are that you could get two heads, you could get two tails, right? The first one could be a heads and the second one could be a tails, and the first one could be a tails and the second one could be heads. Okay? And I want to make a distinction between these two because they are actually two different events. Sometimes when we talk about them, we might say that they're the same thing, but we have to but they're actually two different events. Okay, so if I want to know the probability, and when I write probability, I abbreviate P with a parentheses, the probability of at least one heads, okay, well, what I need to do now is count the particular events. In this case, the events where there's at least one heads. Well, this first one has one heads, this one has one heads, this one has one head. So there's three possible ways for me to get one heads. Okay, and then I have to divide it by the number of events in the sample space, of which there are 4. Okay, so the chances of me getting at least one heads is 3 out of 4, or 75%. Okay, so when we talk about probability, at least in this context, we're talking about counting. We count the number of ways of events that are in the sample space. And the sample space basically means all possibilities given this particular situation. Okay, so we count those events, and then we count the number of particular events that we're dealing with. All right. All right. So let's look at one more example here of probability. You have a standard deck of cards that has 52 cards. I'll post a link here so you can see all of the cards and the configurations. There are basically 13 values, right, from 2 to 10, and then Jack, Queen, King, and Ace. Some of you know this all too well, and some of you are new to this. So I'll post a link so you can see what a deck of cards look like, and then you have 4 possible values, 4 possible suits: spades, clubs, diamonds, and hearts. And in a game of poker, each person receives 5 cards, and this is draw poker, right? The best hand is a royal flush with a 10, Jack, Queen, King, and Ace of the same suit. And we want to know what is the probability of a royal flush. Okay, so this is a tougher question because the sample space is huge. Okay, so if you try to list it all out, it's gonna take you a long time. Okay, so you could have a 2, a 3, a 4, a 5, 6, okay? And then you can think of all the different suits that each of those could have. The tree for this is enormous. So we have to think combinatorially. We have to think in terms of counting, right? So when we say that we get a hand of 5 cards, it comes from a deck of 52. And again, the ordering here doesn't really matter, right? Whether you get an ace first or a jack first doesn't really matter as long as you have the same 5 cards. So there are 52 choose 5 events in the sample space, okay? So the size of the sample space is 52 choose 5, which if you type this into a calculator, you'll see that it is an enormous number. Okay? Now, the particular event that we're working with here is a royal flush. Okay? So that's for you to have a 10, jack, queen, king, and ace of the same suit. Okay? And there are only, and by this one we can actually enumerate because it's pretty small. There are only 4 possible royal flushes in poker. Okay, so you could have and I'll abbreviate this. You could have a 10 of hearts, right? This is like one hand. Let me draw this better. So you could have like a 10 of hearts, a jack of heart, a queen of heart, a king of heart, and then an ace of heart. Okay? So this is one possible event. This is one way for you to get in a royal flush. Okay? And there are 3 other ways, which I will enumerate here. Okay, so there it is. Those are the 4 possible royal flushes. And hopefully my drawings make a little bit of sense. 10 of diamonds, jack of diamonds, queen of diamonds, so on. You could have clubs, 10 through ace, and then you can have spades, 10 through ace. So that's it. There's 4 possible royal flushes. And so the probability of a royal flush would be the number of particular events, there in this case there's just 4, divided by 52 choose 5, okay, which is a pretty large number. All right, 52 choose 5 is 2,598,960. So that's how many different possible poker hands there are. A little bit over 2.5 million. And there are 4 royal flushes that's possible. So the chances of you getting a royal flush or anybody getting a royal flush in an honest game of poker is 1% of 1% of 1% of 1%. Okay. All right. So hopefully between these couple of examples, we get a better sense of discrete probability. And again, it's related to combinatorics because it involves counting. We're counting the sample space and we're counting the number of particular events. As always, ask questions if you need it. Thank you for watching and have a wonderful day.